Hello everyone and welcome to part 2 of our Flappy Bird mobile game. In this tutorial, we will be creating a pipe obstacle class that moves around towards the player. Okay, but first we forgot to do something in the last tutorial, which is to go to Edit, Project Settings and change our default and editor startup map to our Flappy Bird map. Okay, we need to change it so we stop getting this default map. And let's go and open it now. Great. So in our last tutorial, we added flapping system for our character. In case you don't know yet, the character will not be moving at all. We are just flying in place and flapping around. Okay, it's the obstacles that we will be coming our way. Okay, not the other way around. So let's create our obstacle class. Let's go of type actor and let's call it pipe obstacle. Obstacle. Great. Let's close this for now. We don't need any of it. So in our pipe obstacle, we need to create some static meshes components, but for some reason I couldn't find any good ones on the marketplace. So we will be creating our own pipe, and if you don't know, the pipe was gonna look like this. So it has a cap in here and the tube, right? Like this. That's the pipe. So we need technically we need two tubes and two caps. Okay, so that's four static meshes. So let's go ahead in here, maybe private or public. I'm using public. No, no need. Private. U static mesh component. Let's call it top cap. Let's copy paste this 3 times. Let's call it top tube, bottom cap, and bottom tube. Okay, we also need a U property of visible anywhere, category equal components. Let's paste it here, 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 and here. Great. Okay, now let's create them in our constructor. So create, no, not create, top cap equal create default subobject U static mesh component. Let's call it top cap. Okay. Or you know what? Let's create the tube first, not the cap, because the cap will be attached to the tube. So let's just create the tube first. So top tube, and we need to attach it. Set up attachment, the root component. You know what? Let's create a root component because right now the root component is the top tube by default. So we need to create a theme component. So root component equal create default subobject u scene component. Let's call it root. Okay, and we need to set its mobility to movable because we need to move the tubes. So root component set mobility e component. mobility, movable. Great. Let's scale also the top tube, set relative scale 3D to something like f factor 1.3, 1.3, and maybe on the Z we give it a 6. Okay. Now let's create our top cap. So top cap, let's copy this and change the top tube to cap. Let's also set attachment. Top tube. Also, we need it to be independent from the independent scale-wise from its parent. Okay, so we need to set its uh, scale to using absolute. So it has a word scale, not a relative scale to the tube. So whenever we change the tube scale, the cap will not be changed scale wise. Okay, it's gonna stay the scale we gave it. So set using absolute with a scale true. True. And let's give it a scale set word scale 3D a factor maybe 2 point f 2 point f and 0.25. Great. Now let's create our bottom tube. So bottom tube, let's call it, let's change this to bottom. Let's change this to bottom and this one. Okay, and the cap also the same as this one. Great. This should be it for now. Let's go and compile. Okay, and create a class, blueprint class. And it's called PP. Great. We got our components here, but the bottom cap is still attached to the top tube. Let's change it here and compile. Um, okay, so sometimes I don't know why, but the engine just doesn't compile immediately. We have to quit the engine, then launch it from the Visual Studio using Ctrl F5. Okay, so press Ctrl F5. I don't know if it's tended or not by Epic, but it's really annoying. So let's go back, and it's great. It's attached to the bottom tube. Nice. So let's set the meshes here. We don't have a mesh now, so what we need to do is go to settings here, show engine content ticket, go to engine content here and look for cylinder mesh, okay, and let's copy it to our content here. Make sure we copy it, not move it. Let's go here again and disable the show engine content. Okay, so let's call this pipes. Let's go here. And now we can set it to this one, and we can set the bottom to this one as well, and the top cap as well, and the bottom cap as well. So if we separate them, let's say by 200 or 300, 350. No, that's the bottom. Sorry, we need to do this for the top. So 350. Okay, so it's a little bit weird because the pivot for the cylinder mesh is in the middle. So as you can see, it's here in the middle. We need to change it according to the tube. So if it's the top tube, we need to pivot to be on the bottom. And if it's the bottom, it needs to be on the top. So in order to do that, let's drag and drop a cylinder here. Okay, click on it, then go to selection mode and go to modeling. Okay, then when you go to modeling, go to export and edit pivot. Okay, so no, actually, before we do it, make sure we create two copies of it. Let's call this one top tube, top pipe, and let's call this one bottom pipe. Okay, so let's drag here the top pipe first, edit the pivot to be to bottom. Just click on bottom here, okay, and click accept. Then drag the bottom pipe, edit pivot, and to the top. Accept, and we're good to go. Now, if we go back here, as you can see, our top tube has the top cap attached at the bottom, which is nice. And the bottom tube, no, it's not, because we still have it as top pipe here. So let's change it to bottom, and voila, great. Okay, this one doesn't really matter. The cap doesn't really matter which aspect you put it. Let's change this to 350, and 350 will be our gap between the pipes. However, this is right now temporarily, because later on we will create a parameter for it. Okay, so let's make a material for it. Let's go here in our materials folder and maybe change the name of this to emissive color underscore m and create an instance of it. Let's call it emissive brown, because I want the pipes to be brown. So let's go in it and first go into the emissive color, this one, and create a vector parameter. Let's call it color. Let's give it a default value of ones. Okay, and now we need to override this to give it a brown color. Okay, let's go here, select all of our pipes and go to element, materials, element 0, and emissive brown instance. Great. Now if we drag and drop it, we can see our pipe class. Great. Now we need to center it to be equal to the player. So the player has a 210 by 990 on the x-axis. So let's do that here also. So sorry, not this one, this one actually. So it's minus 570. Let's make it minus 6, or make it 0. Let's make it 0. Why not? Okay, and make this 0. Okay, now it's in the same position. Okay, great, great. Now we need the pipe to actually move towards us. So to do that, we go into our class, our pipe class, into ops header, and we need to create a projectile movement. So u projectile movement component, and in here we create a u property visible anywhere, u projectile movement component. Let's call it movement component for simplicity, and here let's give it a category of components. In our obstacle class we need to create the component. So movement component is equal to create default subobject u projectile movement component. Let's call it movement component. First we need to set the gravity scale. Includes game framework projectile movement component. So set gravity scale or gravity scale projectile gravity scale equal to 0, so it doesn't fall down, so it has no gravity. And the initial movement initial speed is equal to move speed, which is a parameter we will create now. U property, edit defaults only, category equal parameters. Okay, float move speed. Maybe give a default value of 500. So movement component max speed is also equal to move speed. Okay. Movement component. By default, the velocity is a vector of 1, 0, 0. So it's gonna move from left to right. And we don't want that because we want it to move from right to left, right? So velocity is equal to f vector minus 1 0.0 f 0, 0, and auto activate true. Oh, true. Okay, let's go here, compile. Okay, go to pipe obstacles, and our movement component is here, and you can see initial and max speed is 500. What else? the velocity is -1, and the gravity scale is 0. Great. So let's see if it works. And it's working. You see, it's moving. Great. Let's take it back further. Awesome. Now, you think we are moving, but it's actually the pipe moving, not us. Okay? Awesome. And maybe let's scale it a little bit more. Maybe like go back here, maybe like 20, or just let's change it from here. Maybe 20. Yeah, 20. And this, the cap, let's change it to, no, the cap, maybe 0.5 and 3, and this, I guess. Yeah, it looks nice. Nah, it's too big. Too. Maybe 2.5. Yeah, 2.5 is nice. Okay, awesome. Great. Now, we need to create a ground for our Flappy Bird. Okay, so let's go to C++ classes and create type actor. Let's call it ground. Let's go to ground header and create u a private u property. Visible visible u property. Okay, whatever. Visible anywhere. And category components. U static mesh component ground mesh. I think that's all I need. Let's change this to false. And now ground mesh create okay. Let's give it a scale of 5. Okay. Let's change to collision to um, query only. Collision enabled, query only, and set collision file name block all. Great. Nice. Okay. Let's compile this. Create a blueprint class. Let's call it ground. Call BP. And for the ground, let's go to fab and search for stylized platformer this one, platformer stylized view bird, and add it to project. So now that our pack is installed, let's go to models, architecture, platforms, and search for this one over here. Okay, and first we need to change the material. Okay, the base platform to onlet. Okay, and we need to connect this here and maybe give it a scalar parameter and multiply maybe 0.5, so it's not very bright. So the lower the value, the less bright it is, the darker it is. Okay, let's close all this. Now let's go to no, okay, that's it. Let's go to our class here and add this model. Where was it? Here. Now models, architecture, platform. This one. So let's add it. Okay. And let's add it to our Word. So no, not this one. The blueprint. Awesome. Okay. Let's center it as at 0, like everything else. And let's fill a little bit here. One more maybe. Why not? Okay. So let's go here and add them to a folder. Let's call it ground. Add this here, pipes. Okay, it's looking good for now. One more thing, we actually need to detach the spring arm from the character when we begin play because we don't want it to go up with him or even down. Okay, we want it to stay uh, in its position. So let's go to begin play and go to spring arm. Okay, detach from parent, maintain your position true, and is it this one? Detach from components. Yeah, that's the one. Detach from component, and the component in our case is the mesh. Okay, so F detachment transform rules, keep word transform to keep it in the word. So let's compile. And if we go now, it's detached. You can see we are, the camera is not going up with us or down. So this one here, I think it's because it's blocking the camera, this little glitch here. So we need to fix the collision, but it's no problem. We will do it later. Let's go ahead and copy paste this like 4 times. or 3 times to have 4 pipes in total. And let's give them a, so if this one is 2400, let's give them a 1000 space between each other. So this one is 2400, so this one should be 3400. Okay, and these are all the pipes we will be needing in our game. We will be reusing each pipe multiple times, as much as we need it. We will not be destroying and creating another pipes because it's it's a mobile game, and for mobile, destroying and creating each time is a little bit bad for performance, for memory performance. We need to we need to reduce the callbacks as much as possible. Okay, so we will be using these 4 pipes only every time. So every time this pipe go off the screen, off the player screen. So let's say this is my screen. Whenever the pipe goes out, it's gonna go back way back here. Okay, we are going to report it way back here, and it's gonna be an infinite loop basically. But first, but first, let's go to our character class. Go to capsule component and change the collision. So collision enabled, we want query only, and we want to ignore everything except for the word static. We want it to be block because our ground mesh is a word static, so we want when we hit it to die, and that will happen because of block. And the word dynamic, we want overlap because our pipe is a word dynamic, and whenever we overlap it, we die. Okay, so this should fix, no, it doesn't fix this, and that's because the spring arm component here must have a spring arm collision test. Okay, so basically we need to disable it. That's the one. Do collision test. We need to disable it, but for the spring arm. So let's go to our C++. We go to spring arm. Do collision test equal false. Now the camera shouldn't do this weird thing it's doing. Let's see. Yeah, it's working now. Great. Awesome. Okay. Okay, and you can get rid of this background now. You don't need it anymore. Awesome. Great. Let's close everything here. We don't need any of it now. What we need is to, well, you know, in how in Flappy Bird, the pipes are placed randomly up or down or in the middle. Right now, we don't have that. Right now, it's everything in the same place in the middle. So let's go ahead and change that. So maybe you are wondering why we scaled them this big. And the reason is because we want it to be so big so that we can change its location, its Z location, without uh, without the player seeing the edge here. Okay, so we need to give it a high value of Z, of vertical scaling, and change its position without this edge here coming to player screen. Okay, that's the reason. So let's go to C++ and go to pipes. We don't need anything else now, just pipe obstacle. Create a function. So u function, let's give it a call in editor. This will allow us to call the function through the editor here. So let's say we click on this pipe and we will have a button here to call the function. Okay, so call in editor and category equal parameters. And the function name is void initialize pipe, and another function called void change gap size, and we need three floats, three variables. So u property edit defaults only, category equal parameters. Okay, 1, 2, 3. And the first one is float min random z location. Let's give it a value of maybe, let's see, minus, yeah, minus 350 is good. Okay, so minus 350. And the second one is max random z location. Let's give it 750 maybe. Let's see, 750. Yeah, that's good. That's high enough for me. Okay, and the third one is float gap size. Okay, and 350. No, not function, sorry. It's 350. Great. So let's create a declaration for these functions. So to initialize the pipe, we need to check. Um, so basically, we are changing the location of the pipe to a random vertical location based on the minimum and maximum floats we defined in here, right? So first, we need to get the actor location, the current actor location. So a vector pipe location is equal to get actor location, and now the pipe location dot z, so on the z axis, is equal to 0. Here we are forcing it to be equal to 0, and the reason for that is later on we need to get a random float and add it to its current z location. So let's say this pipe here, has the location of 520 or 500, let's say, for easier calculations. So when it gets off screen like so, we need to take it way back here and call initialize pipe again, so it has a random location. So let's say 500 here. So, and let's say the random float it got is 750. So what we will do is set its get its current z location and add it to 500. So 750 plus 500 is equal to 1250, and then it will be at this position, like so. 1 second. As you can see, it's very high. It's higher than 750, our maximum random location. So we need to set it to 0 every time we initialize the pipe, because 0 plus 750, or the random float, is equal to this random float, right? So that's why we are forcing it to be 0 every time. Next, pipe location dot z is equal to pipe location dot z plus random float. And the random float is fmath trend range between the min random z location and the max, one second, and the max random z location. There it is. Next, we set the actor location to this pipe location. Okay, great. That's it for initialize pipe. Now for the change gap size. Well, remember how in here in the pipe obstacle we set the top pipe location to be equal to 350. Well, that's our gap size. So here in our C++, we want to get uh, the top tube location, current location. So top tube get relative location. Nope, not readable name. Get relative location, and the z location for this tube is equal to, just a second, is equal to the gap size of our the gap size we desire. And then we set the top tube location to be equal to top tube location. So set relative location, top tube location. Great. That's basically it. Now, if we compile, or we need to call initialize pipe first in the begin play. Now, if we compile, okay, and we go into class parameters, class defaults, parameters, we can see the move speed and min random location, max random, and the gap size. And in here, in the editor, if we search for parameters here, we will find the two function, change gap size and the initialize pipe. So the reason we don't see these variables here in our editor in here is because we set them to edit defaults only. Okay, so if you wanted to go to see them everywhere, we can set it to edit anywhere. This way we can edit them in the editor. Actually, I want yeah, let's set the gap size. Let's set the gap size here to be equal to edit anywhere also, not defaults only. So we can edit it from inside the editor in here. There it is, gap size. Just a second. There it is, 350. Now, let's say we want to change it to something like 600, and we call it change gap. You see the top tube was relocated, and here again. Okay. Now, if you want to call initialize pipe, you will see how it will get a random location. You see, it's random location, but of course for every tubes. For all the tubes, we are changing the location by calling initialize pipe. Okay. So now, if we start the game, we will have different pipe locations, like so. Great. Okay. So now, let's create a function to reuse our obstacles. So when do we reuse them? Okay, so whenever the obstacle gets off the player screen, it's not visible to him anymore, we need to reuse it. Okay, so right now, right now, and right now, whenever it gets off the screen. And to do that, we need to create a function in here, so of type boolean. Okay, so boolean bool is in view constant. Okay, let's create a declaration definition, remove this return statement, and we need the player controller. So a player controller is equal to, let's go to the headers here, include the game's play statics, get player controller, um, get word and 0. Okay, so if we couldn't get the player controller, just return false. So why are we getting the player controller? Because the player controller allows us to access the viewport size and the camera manager. And why do we need the camera manager? Because it's gonna provide us information about the player's view. Okay, so then a player camera manager camera manager oops is equal to player controller camera manager player camera manager. And also, if it's not valid, nope, لا we call it camera manager, return false. Now, if these two are valid, we continue. We get the location of the pipe, get actor location, okay, and we get we want a vector 2D variable. Let's call it screen position, okay, and then let's go boolean is on screen is equal to view gameplay statics. We need to project the word, the location of this pipe, okay, to the screen. So from word to screen. So project word to screen, okay, and the player controller is player controller. The word position is actor location, and screen position, screen position. So what this does is it gets the actor location, which is the word, and it's going to project it to the screen, and the result of this will be put in this variable here, okay, because it's passed, as you can see here. Wait a second. Okay, as you can see, it's a vector to the and screen position. The and means it's passed by reference, which means we can actually what's the word, we can modify the parameter, the screen position parameter, okay. So if it's on screen is on screen and screen width um, screen height, layer, controller, get viewport size, screen width, screen height. So what's happening now is we are checking if the object is within the screen bounds, and we retrieve the screen size in pixels, which is the screen width and the screen height. Okay, then uh, we need to check if the projected screen position is inside the visible screen area. So um, if screen position, so if the screen position is between 0 and the screen width, which means within the horizontal bounds, and it's within the vertical bounds, that means the object, the pipe, is considered visible. It's considered on the screen. Okay, so if between 0 and screen position dot x, screen position, sorry, dot x here, and screen position dot x is smaller or equal to screen width, and the y also is bigger than 0 or equal to 0, smaller than screen height. So if this condition is met, that means return true, pipe is visible. Okay, otherwise, if we don't return here, if we don't exit here, that means it's not on the screen yet, so return false, not visible. Okay, great. So when should we call this function? We should call this function whenever the player gets past this pipe. So whenever he goes through it, we need to call this function. However, we need to call it multiple times because it needs to keep checking and checking and checking until it's out of the view. Okay, so how do we do it? We do it in the tick event. Okay, so here make sure the primarily active tick can ever tick is equal to true, and in the begin play we need to set the active tick enabled to false by default because we don't really need it except for this little time here to check if it's in the view. So now we go into tick and we check if it's not in view. Okay, right now we don't have a function to reuse obstacle. We will create it later on, and we need to set actor tick enabled to false again. Okay, now how do we detect when the player gets past this? We need a collision box over here, which will also will be responsible for our score box. Whenever the player passes, we need to update its score. So let's go to our header, class u box component, and here u property um, edit defaults only, category equal components, u box component, score box collision for components. Okay, let's go here, score box component view box component. Great. Let's set up X first. Let's set up attachment. Okay. And we need to bind a function for function. So score box component um, on component not begin overlap. We need when he passes so on component and overlap. Okay. Dot add dynamic. This a pipe obstacle on score. Let's call it score box and overlap. We don't have this function now. We will create it in a short time. Let's go here and you function void on score box and overlap class view primitive component overlapped component. So now when we overlap this, so if other actor and other actor implement view layer interface um, like so. Let's include layer interface. We get request to the player interface other actor. Okay, so if we cast it successfully, uh, in here we need to call layer interface implement not increment score. We don't have it yet. We will create it in the next tutorial, not this one. So let's comment this now and set actor tick enabled true. So when we press this, okay, we will set this the actor to true, actor tick. This will start calling every tick, and when it's not in the view anymore, we set detect to false, and we reuse the obstacle, meaning it will go back, it will go way back here. Okay, now we have an error here because unscore box and overlap. Um, oh, we forgot here the second one. Yeah, great. Let's compile this. And we forgot that it's a function here, like usual. If I had a dollar for every time I forgot this. Great. So let's go to our pipe obstacle class and let's fill this box to fill the gap. So maybe like so, like so, like so, 95, 95 maybe, 174. Yeah, that's good. Okay. Now let's create our reuse obstacle function. And to do that, first we need to go to our game mode header, and in the private here, we need to create a array, the array of type pipe obstacle. But for now, let's do it of type actor. Okay, and let's call it pipe obstacles. And forward declare the obstacle a pipe obstacle. Great. Now in the begin play here, we need to get a reference to all the pipes, to all 4 pipes, and add them to this array. So outside this if here, view gameplay statics, get all actors of class, get word a pipe obstacle static class. Okay, um, and add them to the pipe obstacles array. Great. What else? Now we need to create a new class, a new interface class for our game mode. So go here, game mode interface. Great. Reload all and create a function reuse obstacle. Let's go here, include game mode interface, public game mode interface. and override the virtual void reuse obstacle override. Okay, um, so how this happens? So when we check for the pipe obstacles, for the pipe obstacle inside the array, for the pipe obstacle that passed our screen inside the array, and then we set its location to be equal to the last pipe, to the last pipe inside the array, so the last index. And then we rearrange the array to make this pipe the last index, okay, and so on, so on, so on. So the second pipe will become the first, the third will become the second, and so on. But I just realized we need to have. Let's go to our game mode, not game mode, sorry, going game mode interface, and add a parameter over here of type a pipe obstacle pipe to reuse. Okay, and let's do it in the game mode too, and in here too. So int index equal pipe obstacles dot index of key by. So this will get an item by key, and uh, the key is obstacle to reuse, the pipe to reuse. Sorry. If the index is different than none, if it's found, okay, a actor last pipe is equal to pipe obstacles dot last, and a, let's cast to it now because this is an actor. Remember, all actors of class return actor, so we need to cast to pipe uh, last pipe. Let's call this last pipe actor is equal to cast a pipe obstacle last pipe actor. Now if last pipe, we need to get the location of the last index, so is equal to last pipe get actor location, and the new location is equal to last index location plus f factor. So the new location of this pipe that we will reuse is equal to the new location, the last pipe in the array. So this one, basically, the location of it plus the difference between each pipe, which is 1000 in our case. Okay, except for this one, should be 6400. So here, uh, plus 1000, 0.0f, 0.0f. So if you use another value here between pipes, just make sure you set the wrong one, the right one, sorry. So if you use 500 between each one, just make sure here it's 500. Then pipe to reuse, set actor location, new location. And when we set its new location, we need to initialize it again. So we have a random size, a random location for it, right? We have a random, no, not graph size. We have a random one like this, okay? So it doesn't always stay the same. Okay, so pipe to reuse, initialize, initialize. Okay, so the pipe is function is in private apparently. Yeah, let's take it to public. Now we can access it. Initialize pipe. Okay, and we need to rearrange the array, and the easiest way to do it is the pipe to use. No, sorry, the pipe obstacle array dot remove at the index we got, and we need to add it again. So right now we removed it from the array. We removed this from the array, which will automatically rearrange the array. So the second index will become the first, and so on. And then we need to add it again after it's arranged, and it will be added automatically to the last index. So dot add pipe to reuse. Great. So now we need to go back to our pipe and create a class, a reference to our game mode interface. So in here, in our begin play, in here, hmm, if the word is valid, which most probably will be, but it's always good to check, a game mode base, game mode equal get word, get authentic game mode. So if game mode interface is equal to cast I game mode interface, and the object is game mode. Okay, great. Now in here, so if game mode interface game mode interface reuse obstacle, and the obstacle to reuse is this one, and set active tick enable false. Let's go and compile. I hope I'm not missing anything. Mm, Flappy mode, Flappy Bird game mode dot h15. Nope, not this one. Oh yeah, it is this one. If I'm not mistaken, I hope so. The error is because in our interface we haven't or declared the a pipe obstacle, and I hope that's it. Nope. Let me check what's happening, and I will be back. So, silly me. The error was we forgot to include the game mode base header. So go ahead and the pipe obstacle CPP include this header over here. Okay, then compile, it will work. So let's check it out if it's gonna work or not. Actually, let's check it out in a big screen, like so. So when it gets off screen, it should, yeah, it's what happened. Okay, it feels like the first one is not setting the correct location. Yeah, it's not. So I think the problem was not through code. Nothing has nothing to do here. Well, the problem is that the pipe obstacle here, the one, is actually the last one, and the two is actually the first one. So the instances here should be initialized properly also. So the first one should be the first one here, because when you get all actors of class and add them to the array, the first one is added. Uh, this first instance is added as the first index in the array. So we have to make sure they are in order here too. So this one here is should be 3,400, and the second should be 4,400. The third should be 5,400, and the fourth should be 6,400. So now this should work, hopefully. So let's test it out. Yep, it's working as intended. Great. And you can see each time it has a new uh, location or whatever. So let's test this in the portrait mode to see how it looks. Great, it's working perfectly. But I also have one issue. The Flappy Bird camera shouldn't be centered in the middle. It should actually be a little bit to the right. So we can see what's coming. So what I mean is the character should be aligned like this, to the right, to the left, not in the middle. So we need to change, where is it? We need to change the spring arm location. So if you go here, we need to change the location. Maybe set this one to maybe 400 and the Z on 150. Let's see now, maybe a little more. maybe 500. Okay, now it's 600 maybe. Yeah, 600 is good. It's not bad at all, actually. Hmm, no, let's keep this one 0. Or, I don't know, you can tweak it the way you like, the way you find better for your game, for your preference. Maybe I'm going to set it to 150. Yeah, I just like it this way better. Okay, great. Now the last thing in this tutorial, we want to bind when we hit the ground or the obstacles. So let's go here to obstacle and create a function, maybe here or not. View function um, void on overlap begin view primitive component overlapped component a actor other actor. Okay, great. That's the function. Let's go ahead. So now in here, um, if other actor um, so if player interface die. Right now we don't have this function. We will create it in the next tutorial, but for now we can just this we wanna destroy the player character. Well, let's go for um, let's just go for right now just screen just to add a print string on the screen. Okay, so the message you died. Okay, and in here top tube on component begin overlap dot add dynamic on begin overlap begin, and let's copy paste this here too, and for the bottom tube. And now for the ground, um, let's go here. You need to also create a function void on head, not overlap on head here. You primitive component, head component, a actor, other actor, you primitive component, other component. Okay, so when if the other actor, so it's the thing same as this one, we are just going to copy paste it like so. No, not this one, sorry. This one, like so, and we need to include this. Great. Now ground mesh dot on component head dot add dynamic this a ground on head event. Let's compile. Let's try it. Um, okay, nothing is happening. Okay, so the reason was, well, there was no reason at all. What I did was just close the editor and then oops, went to the Visual Studio and launched it again using Ctrl F5 or from debug and start without debugging. Then it will work. So if we go now here, if we hit this, it won't work. But if we hit the ground, it's gonna work. Um, I have no idea why. So after like literally about an hour of debugging, the issue was, well, for the ground, I simply just closed the window, the Unreal Engine, and then went to C++, to Visual Studio, and went to debug, start without debugging, and it worked. However, for the pipe obstacles, I have no idea what corrupted the blueprint, but I had to delete the blueprint class, and then create a new one from here. Okay, and then place this again in the work. Right now it's working. As you can see, we are getting UDIT error. And this code, I added this code in here just for debugging purposes also. So yeah, you might not be facing this problem. I think it's only me, hopefully. But however, if you are facing it, that's how you solve it. Stuff can get messy and tricky with C++. So anyway, that's it for this tutorial, guys. Thanks for watching. I hope you enjoyed. Don't forget to like, subscribe, and comment if you have any questions for me. And I will see you in the next tutorial where we will be implementing the dev functionality as well as scoring system. So take care. See you later.